Hello. So we are starting a new chapter, chapter 9, which is about algebraic fractions. So let's get started. For this PowerPoint, learning objectives is simplify algebraic fractions by cancelling common factors. So we saw similar things when we deal with numbers. Now we will do similar things for algebraic expressions. Like dividing a whole number by another one, we can also divide one algebraic expression by another algebraic expression, giving algebraic fractions. Like x over y, x squared plus y, that's an algebraic expression. You divide by x, you get x squared plus y divided by x. You get 3x plus 2, an algebraic expression. You divide by a number, or it's also another algebraic expression. So you get divided by 7, so on and so forth. Well, when dividing, and also for multiplication, the same applies. We need to take care of the sign, right? So if you divide a positive number by positive, you get a positive number. Divide positive by negative, you get negative. Negative divided by positive, you get negative. Negative divided by negative, you get positive, right? Also, we need to be careful with equivalent conditions. So x divided by minus y, it's the same as minus x divided by y. Okay, so I can sort of bring this minus sign up front. Similarly, minus x divided by y, we can write it as minus x over y. So as you can see, this expression right here is the same as this expression, and that's the same as that expression, right? So they are all equal, right? And one more, minus x divided by minus y, it's simply x over y. In a sense, minus terms or minus signs cancel, right? Okay. So canceling common factors. So how do we cancel? Right? On the numerator you have one expression, in the denominator you have another expression, and we want to simplify, right? So canceling the common terms. So we did it for numbers. So let's quickly review. Let's say that you have 3 over 12, right? That's a fraction. So how do you cancel out? How you simplify, right? So to simplify, what we do, we factorize the numerator, right? The 3 in our case, and the denominator, which is 12 in our case, right? And then any factors which appear in both numerator and denominator, so the common ones, right? We cancel them out, right? So in this example, what we have, so 3 divided by 12, so 3 I can write as 1 multiplied by 3, 12 I can multiply. So writing numerator as 1 times 3, denominator as 4 times 3, I see that this 3 and the 3, they are common, that's why I can cancel, right? So I left with 1 over 4. Yes, I could do also like 4, I could write 4 as 2 times 2, right? But that doesn't help because in the numerator I do not have 2 as a factor, so they don't really cancel out, right? So there is no point of writing 4 as 2 times 2. Okay. So let's do more examples. So for each of pair of the expressions, state which factors are common to both. So let's do A. So what do we have? 3xy, 6xz. So we have 3xy. I can write 6xz as 3 times 2 times x times z, right? And then what do I see? I see 3 as a common factor, x as a common factor, 2 is not common, y is not common, z is not common, right? So here the common factors will be 3x, right? Okay, let's do it a bit faster. So about b, I have xy and 5. So I have xy and 5y square. I can write 5y square as 5y times y, right? So now we see that y is in common. So common term would be just simply y. Okay. How about c? So I can write this x plus 2 square as x plus 2 times, okay, let's dot, right, times x plus 2. Now I see that x plus 2 is common to both. 3 is not common. The other x plus 2 is not common. So here the common term would be x plus 2. And finally d. So what do we see? 3 is not common. So x minus 1 is common to both, right? So here the common factor is x minus 1. Okay. Now let's do simplification. So, so simplify 18x squared divided by 6x. So what do we see? Well, I see 6 at the bottom. So how about 18? Well, 18 can be written as 3 times 6. Then I have x at the bottom. Here x squared. Well, I can also write x as x times x, right? Here I have 6 times x. And then I see that x is common, or 6 is common, x is also common, so they cancel, right? And what I get, at the top I get 3 times x, at the bottom I have 1. Or I can simply write as 3x. Okay? So when simplifying algebraic expression, we need to cancel only the common factors. For example, here 3 is not a common factor, so I cannot cancel, right? Or another x, there is no another x on the denominator, so I cannot cancel, right? And a fraction is expressed in its simple form. So what is the simplest form? It means you sort of cancel out all possible common terms, and then what is left? So in this case, it's 3x. So that's what we call it, the simplest form. Okay. Another example. So I have 5 here, right? Well, okay, I can write it as 1 times 5 if I want to. How about the denominator? Do I have a 5 here? Well, okay, one mistake could be, you can do, okay, oh yes, this is, I can cancel. Here is 1, here it's 5, right? You can say, okay, so in here, you can say, well, I'm left 1, here is like 5 plus 15x. No, that's a mistake. You cannot do it, right? You cannot do it. Why? Because here it's an addition. You can cancel out if you have a multiplication, right? So what do I mean here? So again, let's do it 1 times 5. In order to cancel 5, if I want to cancel 5, I should be able to write 5 times some expression, maybe in parentheses, right, in brackets. So indeed, 25 has a factor 5, 15 has a factor 5, so I can factor out 5, right? That's what we learned earlier. So times, this is not x, is times. Here what I have? I have another 5, right? Because 5 times 5, 25. And here I take out 5 from 15, so 3 left. So I have 3 times x left. So now I can, because it's multiplication, I can cancel out 5s. So I left with 1 at the top. At the bottom I have 5 plus 3x. Okay, let's do another example. 5x divided by 25x plus 10y. Again, I cannot say like, okay, let's cancel out those things. And maybe, I don't know, also cancel 5s or here. So you can say, okay, 1 times 5 plus 10y. That's not going to work. Okay, it's not going to work. So what is the correct way? Here, this is 5 times the, let's write x like curly x to distinguish between this multiplication sign. Here, I can do again I can factor out 5, right? Yeah, I can. 5 is common, so let's factor out 5. Then this is multiplication. Here I have x term plus, here what do I have? So if I take out, oh sorry, here I should have not just x, right? I should have 5x, right? And then here I have 2 times y, right? Okay, so again we see that 5 is a common factor, but x is not a common factor. Why x is not a common factor? Because here we don't have x term, right? That's why I couldn't pull out x. So on the top I have left with x, at the bottom I have 5x plus 2 times y. Okay, more questions, examples. Okay, so what do we have? Here I have 4 times x. Okay, here at the bottom I can take out x, right? So what is left is 3x plus 1. So now cancelling out the common terms, I got 4 here, here I get 3x plus 1. Okay, another example. So here I have, if you like, I can write it as 1 times x. Here I can write, I can take out x to factorize. Here I left with x plus 2 inside brackets, and then cancelling those terms, I have 1 over x plus 2 left. Okay, now I have 2 examples, so let's do A. So what do we see from A? Well, I have x minus 1 and x minus 1 terms in common, so I can simply cancel. I left with 2 at the top, so in the numerator, and in the denominator I have x plus 2 term. Wait, sorry, x plus 3 term, right? How about B? So what is it common in B? Well, I can write it as x minus 4 here. If you like, you can write it like times 1, right? If you like. Here, what is x minus 4 square? What does it mean? It means you multiply x minus 4 by x minus 4, right? X minus 4. So now we see that x minus 4 are common. So I got 1 divided by x minus 4 once I simplify. Okay, another example. So that looks a bit tricky, right? Okay, you might at first you might say, okay, there is no x plus 2 term at the bottom, so nothing will cancel. But if you remember, we discussed how to factorize quadratic expressions, right? So here I can write it as 2, 1. So if you multiply, you get 2. If you sum, you get this 3, which is the coefficient of x. So it means I can factorize my denominator as x plus 2 and x plus 1. So now I see that I have this x plus 2 term here and here, so they cancel. Hence, I left with, here I left with 1, right? Here I have x plus 1. Okay, so my last slide. Let's simplify. So let me start with A. So what do we have in the numerator? I have x in common, right? If I take out x, I have 3 plus y in the brackets. How about the denominator? Again, x is a common term, so I can take out. I have x plus 5 in the brackets. So we see that x says cancel. So we get 3 plus y and x plus 5. Okay, P. What is the x squared minus 1? Well, you may remember this difference of squares formula. A squared minus b squared is a minus b a plus b, so we can use it. Here x squared minus 1 squared, so it's x minus 1 x plus 1. How about the denominator? We already did it, right? We know that it's x plus 2 and x plus 1. So now we see that x plus 1 is common to both numerator and denominator, so we can cancel out. At the top we have x minus 1, at the bottom we have x plus 2. Right?